Hello everyone, this is Bandgar S.S. working as an assistant professor at Department of Physics, KTHM College, Nashik. Today we have going to discuss S.Y.B.Sc paper 2nd semester 3 instrumentation. In this video we have to cover up the first topic of transducer, and in this topic we have to cover up the subtopic of displacement of transducer of resistive transducer. So first one is the displacement transducer. So displacement transducers are devices intended to convert the magneto-electric or electrostatic signal. So the displacement is vector quantity which gives a change in position of body or point with respect to a reference point. It may be linear or angular motion, is expressed in a absolute or relative terms. The operating range of linear displacement is few microns to few centimeters, and angular displacement is a few seconds to the 360 degrees. So displacement transducer, it sends the some parameters and gives to the displace or some changing the position of object, that is the known as the displacement transducer. So change of position of body or a point with respect to your reference. So displacement is generally expressed in a linear and angular. So linear motion displacement is in a few micron to the few centimeter, and angular displacement, that is the few seconds to the 360. So displacement transducers is a measurement depend on the transduction principle. So this transduction principle gives three types. First one is the variable resistance type, that is the called the resistive. Second one is the variable inductance type, that is the called inductive, and third one is the variable capacitance type, that is the capacitive. So these three types, resistive, capacitive and inductive, so these are the three transconduction principles used in a displacement transducer for measurement of displacement of the transducer. So variable resistance types, most of the you have to use a potentiometer or strain gauge, or in a variable inductance types you have to use a LVDT and variable reluctance sensors. Now starting with a variable resistance type displacement sensors. So what is the principle of that? The variable resistance transducer elements work on the principle that the resistance of the conductor is directly proportional to the length of the conductor and inversely proportional to the area of the conductor. So we have to know what is the how to calculate the value of resistance. R is equal to rho L upon A. So L is the length of conductor and A is the cross-sectional area of the conductor. So that is the inversely proportional and directly proportional length of conductor and area of the conductor. So that depends the resistance of the conductor. So that is the principle of the variable resistance type. The displacement of an object is calculated by connecting it to the slider. So when the displacement of the object is generated, so it is calculated by using a slider of a potentiometer or variable resistance type transducer. When energy is given to the end object for moving them from its first position or initial position, the slider moves with conductor end. So whatever sliders are given, so it moves with the length of the conductor. So the length of the conductor will change to reflect or modify with resistance of the conductor. So when increase the length of conductor, so it will change the or reflect of the resistance of the conductor also change. We have to know the R is equal to L upon A. So L is the increase, then resistance also increase. This type of transducer, it like as a potentiometer. It work on the sliding contact principle, which used to calculate linear and angular displacement. One most of the popular sliding contact type of variable resistance transducer is the potentiometer. We have already said about that. Depending on the sliding contact displacement, potentiometer dividing into following two ways. First one is the linear potentiometer, that is the called translational potentiometer. The second one is the angular rotary potentiometer. Now, starting with a linear potentiometer used for the measurement of linear displacement. So, linear potentiometer used to measure the linear displacement of the transducer. In this type, the motion of the sliding contact is translated. So, there is the linear displacement. So, what is the meaning by translating? So, that is the unique direction, linear motion, that is known as the translation. So, we have to see in the how to sliding contact move in a linear potentiometer. So, we have to apply some external power supply to the across a wire. So, above we have to use a wiper and this coil across we have to measure a output voltage, that is the E0, and X is the total linear motion or total displacement of the linear potentiometer. So when it is the wiper moves like as a X total X length in this side or this side, so there is the resistance are changes. When sliding contact moves or displays, the resistance between output terminal changes, and so the output voltage also changes. So whenever sliding contact moves, resistance changes, so their terminal output voltage also changes. The change of position of sliding contact changes the output voltage. So it is calculated by the E0 is equal to, that is the output voltage, is equal to R2 upon R1 plus R2 into E. So E is the whatever given voltage source, and R2 and R1, that is the half part of act as R1 and half part act as R2. So R2 upon R1 plus R2 into E. So you will get the output voltage of linear potentiometer. Now, second type of potentiometer is the rotary or angular potentiometer. The rotary potentiometer is used for the measurement of angular displacement. So that potentiometer to measure or calculate the angular displacement of the potentiometer. In this type, the motion of the sliding contact is rotational, so there is an angular displacement. When sliding contact moves or displaces, the resistance between output terminal changes, so that output voltage are also changes. So see the diagram. So there is a wire wound in a form of toroidal rotary form. So their wiper are changes angularly, means few seconds to the 360 degree, and we apply the some external source, that is the E, with respect to wire to end of the wires, and we have to measure the voltage across the wire as well as wipers. So when sliding contact is moves, then or displays, the resistance between output terminal are changes, so output voltage are changes. So combinational of translation and rotational motion of the sliding contact. If your sliding contact motion we have to combine in a translational and rotational motion, then that potentiometer is known as the heliport, or that is known as the helix combination. Now, potentiometric displacement transducer. So which contains main three blocks which performing the operations in a potentiometer. First one is the winding wire. Second one is the winding former. So we have to already know winding wire. It is wound on the winding former. And what is the wiper? Wiper as a sliding. So we have to know as the sliding contact. We have to use it in a linear potentiometer and angular potentiometer. Now we have to see some characteristics of winding wire, winding former, and wiper. So starting with winding wire, the winding wire should possess following characteristics. First one is we have to require a 25 to 50 microns diameter wire wound over a cylindrical or flat membrane of ceramic, glass, and aluminum. Second one, resistivity may be vary normally from 0.4 to the 1.3 micro ohm per meter. And third one is the temperature coefficient may vary 0.002 to 0.01%. The wire should be strong, ductile, and rotating from the surface corrosion by enameling and oxidation. Fifth one is the wire material commonly employed: copper, nickel, common chromium, silver, palladium. And next one is the winding wire can be linear, toroidal, should be possess uniform spacing or constant tension. Next one, 7. The outer surface of wire covered with suitable insulating material to protect against dust and abrasion. Next one, 8. One is the resistant stability with time should be a very high order. The dimensional tolerance should be less than 1%. So these are the characteristics are required for winding wire for giving a desired resistance or desired output voltage of the transducer or potential. Now, second parameter of potentiometer is the winding wire. The winding wire should be possess the following characteristics. So first one is the good dimensional stability and surface insulation. So whatever former we have to use in potentiometer, it has the good dimensional stability, surface insulation, as well as the formal materials are used like as ceramic, anodized aluminum, molded explosives, and steel. These are the characteristics are used in winding former, used in a potential. Third one is the wiper, that is the sliding contact of the potentiometer should be possess following characteristics. The wiper made of material are tempered phosphor, bronze, beryllium, copper, and metal alloys, which is easily moved to over element with minimum friction. Second one, the wiper good contact force and contact resistance, which gives high overall accuracy. And third one is for reduced friction, some conductive lubricants are used. And fourth one is better contact and ability to withstand high shocks and vibration, while wiper and lip spring wipers are designed. So these are the characteristics should be possessed by a wiper or sliding contact of the potentiometer. Then you will get the desired output voltage with respect to potentiometer. So these are the some characteristics should be possessed: winding wire, winding former, and wiper or sliding contact. Then you will get the desired output or desired result of the potentiometer. Now, advantages of potentiometer using as a displacement transducer. First one is it is available in various size and high range of resistor. Second one is these transducer gives quick response. These are available in different sizes and they have high resistance as well as the voltage, otherwise current, for both AC and DC is suitable for calculating variable resistance. Next one is it is the very low cost, it is cheaper. The operation of this transducer is very easy and used in various applications wherever the necessity are not mostly served. These are the used to measure the huge amplitude of displacement. Next one is its electrical efficiency is extremely high and gives adequate output to lead control operation. So these are some advantages of potentiometer when we use it as a displacement transducer as a sensing element. Now next, disadvantages of potentiometer of displacement transducer as a sensing element. When using this transducer, poor dynamic response, so there is no speed of response, poor resolutions, the resolution is not good, susceptibility to shock and vibration. So these are the very sensitive to the shocks and vibration. A lot of power is wasted in moving with sliding contacts. When is the sliding contact moves or wiper moves, so that time we require more power to operate that sliding contact and wiper. Next one is the sliding contacts can produce a lot of noise. So when it is the moves or displace the sliding contact or wipers, that time it produces a lot of noise. Now next concept is the strain gauge. A strain gauge is a register to measure a strain on an object. So it measures the strain on an object. It acts as a register. When an external force is applied on the object due to which there is deformation occurs in the shape of the object, this deformation in shape is both compressive and tensile, is called strain. It is measured by the strain gauge. So when we apply force on any object, that time it performs the deformation like as a compression and expansion, that is known as the strain, which measured by the strain gauge. When object deforms within the limit of elasticity, either it becomes narrower and longer or it becomes shorter and coarse. As a result of it, there is change in resistance N2. So when it becomes a narrower and longer, that is the shorter and longer, as a result there is change in resistance N2. So that resistance is directly depend on the length and cross-sectional area of the conductor. We have to use in a strain gauge. So R is equal to rho L upon A. So rho is the resistivity of the material used in the conductor. L is the length of the conductor. A is the cross-sectional area of the conductor, and R is the resistance of the whatever generated in across it. So next concept is the strain gauge factor. So strain gauge factor we have to calculate to get the desired function of the gauge. So strain gauge work on the principle of conductor resistance, which gives the value of gauge factor by using the below formula. So gauge factor is defined as the ratio of fractional changes in resistance to the fractional change in a length with the known as the strain. So we have to get the gauge. So here epsilon is the change in L upon L, that is the mechanical strain, is equal to absolute change in length to the original. So how much change in length upon original length, that is the mechanical strain. Or change in resistance, the change in strain gauge resistance when due to axial strain or lateral strain, and R is the unstrained resistance of the strain. That is the original or initial resistance of the strain gauge of the strain gauge device. The gauge factor is defined as a gauge factor or strain factor of a strain gauge is the ratio of relative change in electrical resistance R to mechanical strain epsilon. So that is the change in length upon. Now strain gauge has two types. First one is the unbonded strain gauge and second one is the bonded strain. So starting with your unbonded strain gauge, the unbonded strain gauge which are directly bonded onto the surface of the specimen under observation. So that strain gauge is not directly bonded to the surface of the specimen under. So that unbonded strain gauge device is basically free filament sensitive. So where strain is transferred to the resistance wire directly without any. So when changes in pressure in diagram 1 and 3 wire tension is increases, then tension decreases in 2 and 4 wire and vice versa. Means if 1 and 3 tension is increased, then 2 and 4 wire are tension decrease, and when 1 and 3 wire tension decrease, then 2 and 4 wire tension is increased. So that is the working of the unbonded strain gauge. Now whatever resistance changes between these 4 wires 1, 3 and 2 and 4. So when movable parts are displayed, the strain of wires can increase or decrease the resistance. So there is changes of when it is the tensions, so there is tension increase or decrease, so there is the resistance changes accordingly in 4 wires 1 and 3 and 2 and 4. So these wires are connected to the piston bridge, which can be measured very small motion or very small forces. So you will get the output voltage by using a piston bridge. So piston bridge convert that resistance into output voltage. So V out is equal to V in into GF, that is the gauge factor. We have to already know the changing resistance to the changing mechanical strain. So that is known as the gauge factor into epsilon, that is the mechanical strain upon 4. So 4 wires, that's why we have to use the 4. So piston bridge convert that resistance into a output. Now see the application of bonded strain gauge, advantages and limitation. So first, with starting with the application of bonded strain gauge, unbonded strain gauge is used in place where the gauge is to be detached and used again and again. Second one, to measure the stress generated by motion. In the field of mechanical engineering development, in the field of component testing, aircraft like linkage, structural damage, and etc. Another, unbonded strain gauge are used in a force, pressure, acceleration. Now, advantages of unbonded strain gauge. The range of this range is plus minus 0.20 plus minus 15% strain. The gauge has very high accuracy. Unbonded strain gauge can accommodate over travel stop limits. This provides mechanical or pressure protection. They have a low mass or long-term stability. So these are the advantages of unbonded strain gauge. And last one, limitation of bonded strain gauge. It occupies more space. They are sensitive to shock and vibrations. So these are the limitations of the unbounded strain gauge. Now second type of strain gauge is bonded strain gauge. In bonded strain gauge, a wire is bonded to a diaphragm. Changes in pressure cause the diaphragm to flex, which in turn is sensed by the wire. So here strain gauge bonded to a diaphragm. So changes pressure cause the diaphragm to flex, which is turn sensed by the wire. So the strain gauge is bonded directly to the surface of specimen being tested with a thin layer of adhesive silk, which serves to transmit the strain from the specimen to the gauge wires, at the same time serve as an electrical instrument. So the carrier is bonded with adhesive material to the specimen, which permit good transfer of strain from carrier to the field wires. So you transfer the trace from specimen to the wires, so by using a bonded strain gauge. So we have to see in the diagram how to strain gauge bonded with a diaphragm or specimen. Now next one is the advantages of bonded strain gauge. Bonded strain gauge offers a rugged assembly or good accuracy that is not degraded by shock or vibration. So this limitation of unbonded strain gauge is overcome in a bonded strain gauge. It is not degraded or not generates any noise or error because of shock or vibration. It has good sensitivity, have stability even at high temperature. At high temperature, it very sensitive and gives the stable output. It is the very small size shape, so that's why it has good frequency of response and it has the good fatigue of. So these are the advantages of bonded strain gauge. Next, disadvantages of bonded strain gauge. These gauges cannot be detached, used and again. So like as an unbonded strain gauge, we cannot the detached and used again bonded strain gauge. These gauges are costly. So these bonded strain gauge are very costly or expensive. Bonded strain gauge are limited in their pressure and temperature ranges, and bonded strain gauges has some limitation in pressure and temperature ranges. Now, application of the bonded strain gauge. Strain gauge are extensively used in the field of geotechnical monitoring to keep the constant check on structure, dams, tunnels, buildings, so that mishaps can be avoided. As whatever condition we have to control, very serious condition we have to control, so that time we have to use a bonded strain gauge. Bonded strain gauge can measure the torque applied by the motor, turbine, engines, fans, generator, wheels or propellers. So you will find this type of equipments in power plants, ships, refineries, automobiles and industries. So bonded strain gauge mostly used in a very where is the more security or more responsible projects are required for the bonded strain gauge. We have to use. Thank you.